Hello there! In this tutorial we are going to be creating a Mario style overworld. And in here you can move between different stages, and if you select the stage you start a level. And once you reach the end of that level you unlock the next stage. So it's essentially a basic overworld. And this is what we are going to be creating in this tutorial. And the level itself I have made in earlier tutorials, so check those ones out if you want to make the level itself. Now that being said, if you don't care so much about making the levels and you only want to make the overworld, you don't have to watch these videos. So let me explain how this is going to work. Essentially, I'm going to split this video into 3 separate parts. The first part is all about the overworld logic. So in here, we don't have any fancy graphics and we don't have the ability to switch between the overworld and the levels. So we are only going to focus on the actual movement of the overworld, which is going to make it much easier for me to explain how all of this is going to work. Then for the second part, we're going to take the overworld and give it the ability to switch between the overworld and the level, and then switch back again as well. And again here, there are no fancy graphics. As long as you know Pygame, you should be able to follow along. And only for part 3, we're going to take all the content we created earlier and integrate it into this overworld. And along with that, we are also going to give it some graphics, so it looks significantly nicer. And before we start with the first part, I want to do some setup. That's going to be quite important. And there are 2 major things I want to cover before we start with the first part. Number 1, I want to go over the basic logic of our code. So what classes we are going to use. And then number 2, in our code, we have to create some basic setup so that we have the data ready to actually create the overworld. But let's start with number 1, how our code is going to work. And the most essential thing you have to understand here is that we have 3 classes that organize the entire framework. We have a game class, an overworld class, and a level class. And I think the overworld class and the level class are kind of obvious. So the overworld organizes the overworld and the level organizes the level. That one should make sense. But to switch between these 2 classes, we need some other code to organize their interaction. And for that, we have our game class. And literally all this one is going to do is we are going to give it the object of the overworld and of the level, and then we are going to add some code in our game class to switch between the 2. So our game class effectively organizes the entire game and the switching mechanic between the different instances. So that is going to be our basic framework. Now besides that, we will also have to work with quite a bit of data. And let's do this actually in code right now. I think that's going to be the easiest. So let me jump straight into the code and let me explain what we have to do. So here we have a very basic setup of Pygame. If I run all of this, we can see a plain black window. And let me move it to the side a tiny bit. The only 2 things you have to be aware of here is that we have our screen dimension, which are 1280 by 720, and we are filling the entire window with black. That's really all that's happening here. And if you have no idea what any of this means, check out my introduction to Pygame. This one explains the entire module. But alright, there are 2 changes I do want to make. And the first one, I want to put the screen width and the screen height in a separate file. So let me cut them out and open a new file that I'm going to save as settings.py. And I'm just going to paste the screen width and the screen height in here. And then in my main file, I want from settings import everything. So now if I run this, we can see that there's no difference. So this one is still working fine because we're still using the screen width and the screen height. And the only reason why I am doing this is because later on for the level and for the overworld, these 2 variables are quite important. So I want them to be available everywhere. And for that, having them in a separate file makes a lot of sense. And you are going to see this in practice later on. It makes our life quite a bit easier. So alright, that's going to be the first part. Now for the second part, the important thing for our level is that we actually need some data, which we don't have right now. So think of for the most basic setup for our game. We need a couple of data points. And in my case, there are 3 bits of data that I really need. Number 1 is the position of each of the stages, so I know where to put them. Then number 2, I want to know what content actually goes into each level. And for the simple setup, we just have a string of text. But later on, the content for the level is going to be much more elaborate. But in either case, we need to know what we actually want to put inside of each level. And then finally, for each level, we also want to know what next level is going to be unlocked. So these 3 bits we really have to know. And I've put all of those into a separate file. So let me go back into the code and let me explain this. So here we are back in the main file, and I want to create a new one. Let me save it, and I call this one game_data.py. And in here, let me just copy 1. So here we have level 0, and this is literally just a dictionary with 3 bits of information. We have the node position. This one is just a tuple with x and y. Then we have the content, and this is just a string. So in the simple setup, we are just going to show a simple string, nothing else. And then for the 3rd bit, we have what level we are going to unlock once we are finishing the level. And this would be 1 level. But in my case, I have 6 levels in total. So let me copy all of them. And this is going to look like this. So the data here looks very similar, but if you look a bit more closely, we have different positions for each of the stage. I call them nodes. Then we have a different level name, so level 0 to 5. And then for the unlock, we have level 1, 2, 3, 4, and 5. And I guess the one important thing here, for the final stage, we are not unlocking a new level, so this bit here. Instead, we keep on the same final level, because we don't have a level 6. But that really is all you need. It's very basic dictionaries. Now there's one more thing I do want to do. So when I want to work with this data here, it would be kind of a pain to always import all of these levels. So instead what I have done, I have put each level in another dictionary, which looks like this. So in here we have a key of 0, and then the value is level 0, so the one we created up here. And this we have done for all of the levels. And that way I can work with the data very easily, because all I have to import is this levels. And this didn't necessarily have to be a dictionary. A list would have worked here as well, but I feel like a dictionary makes this a bit more clear. But alright, now we have all the data that we are going to need to get started on the overworld. So, well, let's start working on the overworld. And to get started with our overworld, there are 2 classes I want to create already. My game class and my overworld class. And the game class for now isn't really going to do anything. It's just going to run the overworld class. But later on, we are going to make the game class much more useful. But I guess let me go back into the code and let's actually work on this. So here we are back in our file, and all the way at the top, let me remove the white space here. All the way at the top, I want to create a class called game. There's no inheritance, but we do need an init method. And it needs self and nothing else. And for now in here, I just want to create self.overworld, and this is going to be overworld. And this class does not exist yet, but we are going to make it in just a second. Now, besides that, I also want to create a method I called run. There are no arguments besides self, and all we want to do in here is self.overworld.run. So essentially, in this overworld class, we are going to create a run method. And this run method we are going to call in here, and then the run method of our game we are going to call inside of our game loop. And that way we can organize the entire logic of our overworld inside of this class here. We don't have to really do much in our main class, which helps us to keep our code nice and clean. So, alright, the last thing I have to do is to create an instance of my game class. So it's just going to be game. And then in my game loop, I can call game.run. And this should be all we need for now. So now we have our basic game class. And with that, we can create the overworld. And this I want to do in another file. So let me create a new one and let me save it as overworld.py. And in here, there are two things I want to import. Most importantly, I need Pygame, as always. And then besides that, I want from game_data import levels. So this is going to be this dictionary here. And now once we have that, I want to create a class overworld. Again, there's no inheritance, but we do need an init method. And we have to start with self. And now we have to add a couple of different arguments in here. And this could actually be a really good exercise for you. Try to think of what kind of parameters we are going to need to make the overworld work. All right, let's go through it. Now, in my case, there are 3 different arguments I need for now. The first one is going to be the start level. So this is going to be on what stage our player is going to start. And this is just going to be an integer. So a number from 0 to 5. Then next up, we want to have a max level. So how many levels are going to be unlocked? And then finally, I want a surface on what to draw the entire level on. So this will be the display surface. And well, once we have all of that, let's add a comment here and let's call it setup. I want my self.display surface, and this is going to be the surface. Then I want to have self.max level. That one's the easiest one. And this is going to be max level. And then finally, we have to change the name here a tiny bit, because I want to have a self.current level. And this is for now going to be my start level. So why did I change the name here? And well, the answer is quite easy. So let's say later on we have our overworld, we have stage 1, stage 2, stage 3, and stage 4. And when we start, we are on this node here. So this would be our start node. However, while our overworld is running, we might move to a different node. So maybe this one, maybe this one. That was a terrible arrow. Maybe this one, that looks better. So we can move around with our node. Hence, we have to call this one the current node. But when the level is starting, our current node is going to be the start level. So with that, we are using all of our parameters. We are also going to integrate levels into this class, but we don't need them for the parameters because we always have this one available. So, all right. So the last thing we need back in this game class, we have to give this overworld a couple of arguments. And let me actually copy all of them so we can go through this one by one. Now for the start level, for now, I just go with 0. That one's quite easy. For the self.max level, I'm going to create a separate attribute. And let's call this self.max level. And let's say for now, let's put it at 3. So self.max level. And then finally, the surface that we want to get is just this screen one here. So we're just going to pass this one in there. And then we should be good to go. So all I want in here is screen. So that way we are creating our overworld. Now the last thing we are going to need in the overworld, this one is going to need a run method. And for now, let me just add pass in here to see if it's working. So now, back in my main file, let's run all of this. And we get an error because, as always, I forgot from overworld, import overworld. There we go. Now this is working. So this is looking quite good. Cool. So this way we have our basic setup for the game class that we are going to need. Now we can focus entirely on the overworld and create, well, all the stuff we are going to need. And let's start by putting on the stages on the screen. And I wasn't really sure how to call them, so I generally stuck with nodes, but it's just the stages that we can move between. I couldn't really think of a good name for them. And I want to add another comment here, and this one I want to call sprites, because all of the nodes and the player icon are going to be sprites, which is going to make it much easier later on to customize them. And in here, I want to have one argument for now, and I call this one setup nodes. And for that, we have to create setup nodes. Doesn't need any arguments. And really, all I want to do in here, let me open my game data. Essentially, all I have to do is to go through each of the position information and then place a sprite in this position. So I want one sprite in this position, one sprite here, and so on. So this is going to be a for loop. So let's call it for node data in levels.values. So we're getting this levels here, and we get all of the values. And this way we're accessing each of these dictionaries. And let's actually print and see what we are getting. So print node data. And back to my main file, let's run all of this. And there you can see all of our node dictionaries. So this is working. Now obviously I don't need the entire dictionary. All I really want is the node position, I think I called it. Yes. So now if I run this, I get the position as a tuple, which is quite useful. So this information I can use to place a sprite. But to place a sprite, I need two things. First of all, I need a sprite group. And that one, well, it's very easy. Let's just call it self.nodes. And this is just going to be pygame.sprite.group. But, well, now we actually need a node class. And this I just created on top here. So class node. And this one has to inherit from pygame.sprite.sprite. And in here, as always, we need an init method that needs self. And now there's one more argument I do want to pass in here, and that is the position. And later on, we are going to add a bit more, but that doesn't matter so much for now. And then here, I want to have a self.image, and this is just going to be pygame.surface. And in my case, I made this 100 pixels wide and 80 pixels high. Then self.image.fill, and I filled them with red. And then self.rect is just going to be self.image.get rect. And the center is going to be the position. So this is a very, very simple sprite class. Really not much is happening here. But now that we have that, I can go back to my setup nodes method and get rid of this bit here. And let me cut this bit out. And instead what I want to do, let's call it a node sprite. And this is going to be a node. So we're just creating an instance of this node class here inside of this for loop. And this one wants one argument, the position, and the position we have. That's our node position. And now finally, self.nodes.add and the node sprite. And now in our nodes class, we should have all the sprites in the right position. So in my run method, I can get self.nodes.draw. And now I need the surface I want to draw this on. And this would be my self.displaySurface. So let's pass it in here. And now when I go back to my main file and run this, we are getting an error because we have node object has no attribute sprite G. And this is a very common mistake in Pygame. All it really means is inside of this init method, I forgot to call the super.init method. And now let's try this again. And this is looking significantly better. So each of these red rectangles is going to be one of our stages or our nodes. So this is working quite well already. But now we have a problem. Actually, let me go back to the main file and let's run this again. So right now you can see that all of our stages are red, which in my case means they are available. But if you look back in our main class, I want to have my max level at 3. So if this is level 0, level 1, level 2, level 3, that's a terrible 3. That's still a terrible 1. 3, that's a bit better. So we have 4 and 5. I only want them available until this point here. So this rectangle here and this rectangle here should be grayed out. So let's work on that. And let's go back in our overworld class, and we have to work in this for loop to figure out how to give each rectangle either a red or a gray color. And the logic here is actually quite simple. Essentially, what I want to know is the index of this node data. So for each for loop, I want to know if this is the stage for level 0, level 1, level 2, and so on. And then I'm going to compare this against our max level. So for example, if we have stage 0, stage 1, and stage 2, each of these for loops is going to be one level. And really all I want to check is if this number is smaller or equal to max level, and if that's the case, it's going to be red. Then the same for this one, and the same for this one. And once the index is greater than self.max level, we know the level should not be available anymore. Quite a simple logic actually. And the first thing we need for that is the index of where we are in the for loop. And this we get with our enumerate method. This one is going to give us our node data, but along with that, also let's just call it index. So this is just going to be 0, 1, 2, and 3, depending on where we are in the for loop. And now all I want to do is if index is smaller or equal than self.max level, and only if that is the case, I want to add my nodes. And now let's try this again. Now we can only see level 0, 1, 2, and 3, but not 4 and 5. And if I change my max level to, let's say, 2, I can see only the first 3 levels, so 0, 1, and 2. And that means the logic here is working. Cool. But now I don't want these other levels to disappear. Instead, I want to draw them gray. So in this for loop, if our level is greater than max level, so else, I still want to draw them. So I also want to create a sprite. And then all the way at the end, I want to add the sprite. So now we have to figure out another argument we want to pass in here to tell if the node is available or locked. And well, let's just give it a string. Let's call it available. Or if that is not the case, locked. And with that, we have to go to the node and let's call this one status. And really all I want to do in here is if status is equal to available, then I want to draw it red. And if that is not the case, so else self.image.fill with gray. And well, let's try this now. And there we go. Now we can see the stages that are available are red and all the other ones are gray. So this is working quite nicely. Cool. So with that, for now, I can hide my node class and focus more on the overworld itself. And the next thing I want to work on is the path between each of the nodes. And that is going to be another method. And let's call it draw paths. It needs self and nothing else. And in here, we need the Pygame method to draw a line. And this one is called pygame.draw.lines, which, well, draws a couple of lines. And this one has a couple of arguments. The first one is the surface to draw on, then the color, then a fill argument, so if it's filled or not. Then it wants a list of points, and then a line width. So we have to figure out all of these arguments, and most of them are quite easy. So surface is just going to be our self.displaySurface. Then for the color, I just want to go with red. For the fill, this is false because I do not want it to be filled. And for the line width, I went with 6. But here, choose essentially what you think looks good. Now, the final thing that we are going to need are the points. And Pygame.draw.lines literally just wants a list of points. So essentially, back in here, what Pygame.draw.lines wants is a list with these points. And there are quite a few different ways to get them. In my case, I'm going to use list comprehension. So let's add points here. And this could actually be a really good exercise for you. So write a list comprehension that goes through all of the dictionaries and get the node positions. And along with that, also try to add some additional code that we only get the node positions for the active levels, so not for the logged ones. So should be a slightly longer list comprehension. So let's do it together now. And first of all, I want to have a for loop. So let's say it for node in levels.values. And let's call it here node as well. So with this, we would be getting the entire dictionary here, which we don't want. We only want this node position. So for this node here, I want to add node position. And that way we would only get each of these positions. And this should already work. So back in my run method, I want to self.draw paths, and let's try this. And there you can see we already have our path. Now, right now, there are two problems. The first one is easy to fix, that our path is on top of the nodes, which is, well, kind of ugly. And to fix that, all we have to do is move this draw paths before nodes.draw. And if we run this now, this is looking much better. But now we have another problem, that this path here, and this path here should not be there. So we have to get rid of them. And for this, let me go back to my for loop. We have to add an if statement in here, very similar compared to what we have done in here. All we have to do is to put this levels.values in an enumerate method, just like we have done here. And if we do that, we also get an index. And now we can use this index in an if statement. So at the end of this list comprehension, I want if index is smaller or equal than self.maxLevel. And if I run all of this, we get the proper setup. So this is looking really good. Cool. And I guess this is something very specific to Python, that list comprehensions are incredibly useful, but if you're a beginner and you're reading all of this, it's probably slightly confusing. I guess let me know if you want me to make a specific video on list comprehensions. That can be quite confusing. But if you understand them, they are incredibly powerful. So with that, we have our draw paths and our setup nodes, and lots of this stuff is really coming together. So with that, we can start working on adding the player to this. And I changed name here from player to icon in the overworld, because our actual game already has a player class, and I didn't want to confuse the names. So the player we are controlling in the overworld is an icon. And well, all I want to do is to create a new class that I called icon. And this one, again, is going to be a sprite. So pygame.sprite.sprite. And in here, this needs an init method as always with self and position. It's actually going to be very similar compared to the node class. And what I want to do in here is self.image is going to be pygame.surface. And I made mine 20 by 20 pixels high and wide. Then self.image image.fill. And I filled this one with blue. And then self.rect is going to be self.image.getRect. And the center is going to be the position. So as always, a very, very simple sprite class. So let's minimize it now. And then in the overworld class, self.setupIcon. And this again has to be its own method with setup icon. And in here, first of all, I want self.icon is going to be pygame.sprite.groupSingle. So we have a group for the sprite. Then next up, I want to actually create the sprite for this icon. and this is going to be just an icon class. And now we are going to need a position. So right now we have a couple of different nodes with a separate index, so 0, 1, 2, and so on. And all we are going to do for the icon is to place it in the same position of one of these levels. So for example, if our current level is 0, we are going to place it in here. And this is a terrible drawn 0. That's a tiny bit better. I guess it makes sense. So really, all we want to do is to get the index of our current level and then use that to find the node where we want to put the player. And there are a couple of different ways to achieve this. You could either use our level, so all of this, or you could also use the self.nodes class and go for that, and then look for the rectangle positions. And let's actually go with that. I think that makes a bit more sense. So I want to get self.nodes.sprites, and this is going to give me a list of all the sprites inside of the nodes class. And I can use indexing here. And I want to get self.currentLevel. So the one we created quite a while ago, this one up here. Right now, it's going to be 0. And this we're just passing in here. And this would give us one sprite. But we want a position. So what we want to get here is to get the rectangle and then the center of that rectangle. And this would then give us a position. And once we have that, we get self.icon.add and the icon sprite. And now with that, in the run method, we can run self.icon.draw and self.displaySurface. And let's see if this is working. And it is not, because as always, I forgot to call the super.dunder.init method. Now let's try this again. And there we go. Now we have our player. And the position here right now is determined by this number, so our start level. If we were to change this to, let's say, 1, our player would be here. But for now, I want to keep this at 0. So we are all the way at the start. And now with that, we have all we need to get the movement. And the movement is going to be slightly more complex. So let me first go through the entire process, and then we'll go through it step by step. Now, the first thing we need for the movement is to get some kind of player input. In my case, I will just check if the player is pressing left or right. And then we're going backwards and forwards respectively. Now, once we have the player input, we are going to use that to calculate the angle the player has to go with. And this we're going to do by getting the start position and the end position. And then literally all we're going to do is to move the player in the direction it's supposed to go in. So this would be step 2. We have a moving player. And then in part number 3, we are going to check the collision with the player icon and the target. And once there is a collision, we are going to stop the player. So that way it's going to stop once we are reaching the destination. So that's going to be quite a few different parts. Let's go through them step by step, straight in the code. So here I am back in my overworld class, and let me minimize everything that we don't need. And the first thing I want to do is to get an input method. And let's call this input. It needs self and nothing else. And in here, I want to get keys, and that is pygame.key_get pressed. And then in here, if keys and pygame.kwrite, then let's for now I just want to print something. So print move right, and if keys pygame.kleft, then I want to print move left. And then obviously in the run method, let's put this right at the beginning. So self.input. And let's try if this is working. And we're getting an error message because this here should be a dot, not an underscore. Now let's try this. And now I can press right and left, and we get the right position. So that way we have our basic player input. Now, essentially, all I want to do in here is, instead of printing left and right, I want to get my self.current level and either add +=1 or self.current level and -=1. So this way I'm going to move forward and backwards. But right now this system has a couple of problems, because let me draw a couple of nodes again. So this would be 0, 1, 2, and 3. And by default our player is here. And essentially what I want to do, if we're moving right, we go this way, and if we are moving left, we are going this way. And here you can already see the first problem, that if we are on level 0, we are not supposed to be able to go backwards. So this should not be possible. And along with that, once we are on the final stage, so in this case number 3, we should not be able to move to the next one because it doesn't exist and we would get an error. So we have to add some extra statement in here that we can't exceed the level number and we can't go below 0. And this, I think, could be a really good exercise for you. Try to expand the if statement that if we're moving to the right, we can't exceed the highest level, and if we're going to the left, we can't go below 0. So let's do it together now. And let's start with the easier one, moving left. That in here, we are checking if we are moving left, but I also want to check with an AND statement that self.current level has to be greater than 0. So once we are equal to 0, this is not going to be possible anymore. And that's all we needed. Now for moving right, this also isn't all that much more difficult, because all we want to get is self.current level is smaller than self max level. And since our max level is never going to be greater than our amount of levels, this one is also going to work by itself. And this one is also going to limit us to our currently active levels. So it kind of pulls double duty. And we could actually already make this work. So let me create another method. And let's call this update icon position. It needs self and nothing else. And all I want to do in here is to get my self.icon.sprite.rect.center. And this I want to set to self.nodes.sprites and self.current level and then rect and center. And this is a fairly long line, but not one that's particularly difficult. Essentially, all that we are going to do is, let me scrub a tiny bit. We first look at the center of our icon. So this icon here, that stands for our player. And we're going to set this to the center of one of the nodes. And which one is going to be determined by our current level. And now all we have to do is to call self.update icon position. And I guess let me put it here. And now if I run this, it's still working. If I press left and right, this is kind of working, but we are moving way too fast. And to fix that, you would have to add a timer in here. Now in my case, I am not going to do that because we are going to organize the movement differently anyway. But if you didn't care about the movement, this would already work by itself once you have a timer. But in my case, I don't really want to do this kind of movement. So let's get rid of it for now and let's add a pass in here. But I think at this point, we can actually start talking about how the actual movement is going to work. So let me explain this right in here and let me draw it again. So let's simplify all of this massively. So right now, we only have two different stages. So we have one stage here and we have one stage here. And right now, our player is in stage number 0. And we want to get from this node all the way to this node. So we have to find the direction of this arrow. And the easiest way to achieve that is to use vectors. And well, once you have a vector, all you really have to do is to get the position of this stage here, then the position of this stage here, and then subtract the latter from the former. So if this is stage 0 and this is stage 1, all we are really going to do is 1 minus 0, or whatever specific position they have. And that is very simple vector math that we can work with. But I guess let me go through all of this step by step. And for now, let's work on this only for moving to the right. So in here, I want to create a new attribute that I called move direction. And this value we get from another method that I have called get movement data. And for now, we don't have any arguments in here. And let's create this method. So I want to get movement data. We always need self, but for now, nothing else. And now we are going to need two different vectors. We first need a start vector, and then we need an end vector. And really, all we're going to do in the end is to return the end vector minus the start vector. So let's actually find all of this. Now, first of all, we actually need a vector too. So pygame.math.vector2. And I want to check the position of our current node. And this we have done earlier already. So self.nodes.sprites. And in here, I want to get my self.current level, and then rect and center. So this is the position where my player is also supposed to be. Now, next up, we are going to need the end position. And the end position is basically identical to this one. So let me copy all of it, with one difference, that now we don't want the current level, instead we want the next level. And let me actually illustrate how the math here is going to work. So right now we have a start and an end node. And let's say the start node is pink and the end node is yellow. Now the start node has a position of 110 and 400. And the end node has a position in this case of 300 and 220. And really, all we're going to do here is this operation. So we get the end node and subtract the start node from that. And the result is going to be 190 and negative 180. So we first do this operation here and then this operation here. And then this is going to be the arrow we have to move along. And I guess let me draw this in a slightly different way. So let's say here we have our start position, here we have our end position, and then the arrow we just calculated is this one here. So this is the arrow we just get. So this is our direction. The problem right now is that we don't want to have the full arrow. Instead, we only want to get the direction. And to turn this from a whole distance to just the direction is by normalizing it. And let me get rid of all of this. To normalize a vector, all you need is .normalize. And this way, we are giving the vector a length of 1. And I guess here, the vector math can get a bit complex. But there are lots of videos on YouTube to explain this in quite a bit more detail. I would recommend to check all of those out. Now, there are a couple of things we first want to do. First of all, this move direction doesn't exist by default. So let's say in my init method, I want to add another section. Let's call this movement logic. And in here, we have self.move direction. And by default, this one is going to be a pygame.math.vector2 and just going to be 0 and 0. So this would be our direction. But I also want to give this a self.speed. And let's put this at 8 for now. And now, in our update icon position that we still kept around from earlier, I want to get my self.icon.sprite.rect.center and just plus equal self.moveDirection multiplied by self.speed. So let's try this now. And let me move to the right. And we get something weird. And this might seem strange. So let me illustrate what is going wrong here. Let me go back to my overworld. And when we move to the right, let me actually print the move direction. And now if we press to the right, and we press right, we get an error because it's, well, self.moveDirection. Now let's try this again. And now we get something weird. That initially we have one movement, then we get a different movement. And you might get an idea of what the problem here is. And let me open this again. So right now we haven't pressed anything. We are on the first node and we want to go to node 1. Now the problem is, if we are pressing right, we think we are going this way, but in reality this doesn't happen. Because when we press to the right, Pygame sees first this position, but then it checks the keyboard input so fast that instead of going to 1, we go straight to number 2. And that way we get 2 different movement directions. And Pygame is going to use the last one, which is why our movement went something down here. And actually let me press to the right, and yeah, something like this. So the problem here was entirely that we have to stop our keyboard input once we are reaching this stage here. That's the entire problem right now. Although there's one more problem I am going to cover in just a second. So the first thing I want to do is, after we have pressed our button once, I want to stop getting keyboard input. So let me close all of this and let me go back, and I want to put all of this inside of an if statement. And let's call it if not self.moving. So once we have pressed something, I want self.moving to be true, and only once this is false, we are able to move again. So after we have pressed left or right, self.moving is going to be true because we are, well, moving. And now let me actually create this as an attribute as well. So self.moving is by default going to be false. And now let's try all of this again. And now we get a much better movement. So the math here is correct. We just had another error. But now let me run this again, because we are still not hitting the right point. So the point we want to hit is this center here. But look very closely once I start the movement. We are not actually hitting it. So our icon actually moves something like this. So why are we missing the target by such a noticeable margin? This really isn't going to work for our game. And the problem here are rectangles. So let me explain this one. Essentially, when we place our icon class, we're always placing a rectangle. So this rectangle here. Now the problem is, when you place a rectangle, you always place integers. So let's say this rectangle right now, the position is something like 100 and 150. But you would never be able to place something like 150.5. If you had a double like this, Pygame would just convert this to an integer and you would be at 150. And in most cases, this really doesn't matter. Nobody really cares. Now in our case, this is different because, let me go down here. This movement direction is going to be 2 doubles. So a double for the X movement and a double for the Y movement. But now the problem is, if this movement direction, let's say this movement direction here, is something like, let's say 0.5 and let's say 1.2, just completely random numbers. Now, if Pygame sees these two numbers and wants to convert them to the position for a rectangle, it is going to change them to 0 and 1. So the numbers are broadly correct, but there is going to be a slight offset. And then every time we are using this position to move, we are going to have a slight different from the actual position. And this is what we have seen earlier, actually. So let's say what we have seen in the game earlier. Here was our starting position, and here was our target position. And the correct path would have been the yellow one, so this one here. But the problem is our purple one, so the one we actually got by placing the rectangle, had a slight offset. So instead of having the correct path, we went something like this. We still had broadly the right direction, but there was a slight offset, which would be very bad for our actual position. So this is what we have to account for. And fortunately, this is quite simple to fix. So in my icon class, I want to create another attribute. Let's call it self.pos. And by default, this is just going to be the position. And for now, this is going to be 2 integers. But then when we do this part here, so when we update the icon position, we are not moving the center of the rectangle. Instead, we are only updating this position. And since this pos is not used as a rectangle, this could perfectly fine be 2 doubles. So this way, we already have the right position. And now, all we have to do, in the icon, we have to call an update method. It needs self and nothing else. And now self.rect.center is going to be self.pos. So this way, we are going to update this position here. And this one is always going to have the right position. So there's no margin at all here. And this we are using for the placement of the center of the rectangle. And this way we prevent our movement from adding a tiny bit of an offset every time we are moving. So this should then be working. So now, all the way at the bottom, besides update the icon position, I also want to get my self.icon.update. And now let's try this again. And now we get finally the actually correct position. That was quite a bit of writing, but now we do have the right one. Now there's one more thing we do need to do. That right now we also want to get the left movement. And to get that, first of all, we do again want to get the movement direction or the move direction. But now we have to add an argument in here that we ever want to move to the next node or to the previous node. And this I want you guys to do as an exercise. Try to add one argument in here and then update this method so that we are moving in the right direction. So pause the video now and try this yourself. All right, so in my get movement, I want to add another parameter and let's call it target. And now in here, my start node is always going to be identical. So this one we can leave as it is. The one I do want to change is my end node. So if target, we need an if statement as well. So if the target, let's say, is next, then my end node is going to be the next node. However, if that is not the case, so else, then my end node should not be the next one. Instead, it should be the previous one. And that is really all we needed. So now when we actually use the get movement data, the first one or the one to the right is going to be next. And the one to the left is going to be, let's call it previous. And with that, let's go to my main file and let's place our icon at position 1. So let's try all of this. It's still working. And now if I press left, we are moving in the right direction to the left. Cool. Now, obviously, our player can only move once and we are never stopping. So let's start working on that. That once we have hit our target, we want to stop the movement and set self.moving back to false so that we can move to the next node. So let me minimize the get movement data. And now we want to work in update icon position. And I guess the first thing that we can do in here is to add an if statement, that if self.moving and self.move direction, only if we have those two attributes we actually want to move. Otherwise, there wouldn't be any point. And this is going to make our code a bit more organized. I think this is better. But all right, now, if that is the case, we want, first of all, to get a target node. And let's put this in a separate variable. And well, the target node is going to be self.nodes.sprites. And in here, we want to get self.currentLevel. Because remember, after we are calling this here, if we're moving to the right, we are updating our current level. So we already have the level we want to move towards. So when we are calling all of this, our current level is going to be our target level. And now I want to check some collisions. However, I don't want to use, let me go all the way up. I don't want to use the entire surface for a collision because that would look very strange. That once we are hitting one of the targets, we are moving straight to the center. So the collision zone that we want to hit should be much smaller. So instead, let me create another attribute inside of the node that I called detection zone. And this is just going to be pygame.rect. And in here, we have to add a left, a top, a width, and a height. And now for these dimensions here, we do have to be careful. Let me minimize the icon because they have to be relative to the speed. And let me explain why. And let's move up a tiny bit. This looks good. So let's say this node here is this orange rectangle. So this is going to be our target. And inside of that, we want to have a detection zone. So this would be something like this. And this is fine by itself. The problem that we have to be aware of, that let's say if our player comes from this direction and the player moves at a certain speed. So at the first point, the player is here, then the player is here, then the player is here. And the distance between these points is the speed. So the speed we have set down here. Now, if we are not careful and this detection zone is too small, there's a chance that our player reaches this point here and then this point. So we are skipping the entire detection zone, which would then mean that our player is never going to stop. And the easiest way to avoid that is to make sure that the entire width and height of the rectangle is equal to the speed. That way it can never jump over it. So graphically, this would look something like that our rectangle is just large enough to always include at least one point of our speed. So really all that means is that the size of this rectangle has to be relative to this speed here. That is really important. All that means in practice is that when we create this node, we get, let's call it the icon speed. And we're using that information to set the size of this rectangle. And really, all I want is to get my icon speed for the width, my icon speed for the height, and for the left point, all I want is self.rect.centerx, so the horizontal center of my sprite. And from that, I want to subtract icon speed divided by 2. And this, let's put it into brackets. And well, this we also have to do for the top of this rectangle, except now I want center Y. And with that, we should have a proper detection zone with a fairly long line of code. And let me remove some spaces in here. Can we get the entire thing visible on the screen? Probably not. All right, but we can see most of it. And I think the logic here is fairly simple. So, all right, with that, we can go all the way back down here. And now, oh, wait, before we do that, when we set up our nodes and we create this node here and this node here, we also have to add self.speed. Very important. So now we set up the nodes properly. So now we can hide this thing again and not worry about it ever again. So now our target node is going to have a detection zone. And this is just going to be a rectangle. So all we really have to do in here is if target node dot detection zone dot collide point, and the point we're looking for is self.icon.sprite.position. So really all we are checking here is the collision between this point here with this detection zone. And if that is the case, I want to set self.moving back to false, and self.moveDirection is going to be pygame.math.vector2 with 0 and 0. And once we have that, let's try this. And there we go. Now our player or our player icon is moving perfectly fine. We still can't access the locked levels and we can't go below 0. So this is working really well. So now let's start talking about the second part. And in here, we essentially have to cover two things. Number one, we have to create a basic level. And this really isn't going to be much for now. We are literally just going to show a plain text. But later on, this is going to be a proper level. And the setup for both is going to be identical. So the work we are doing now is going to be very useful later on. And then for the second part, we have to figure out how to switch between the overworld and the level. And that is going to involve moving around a couple of methods. But let's go through this step by step and let's first create a level. So here I'm back in the main file and I want to create a new one that I'm going to call level.py. And in here, first of all, I have to import Pygame. And along with that, from settings, so the one we created earlier, I want to import screen width and screen. And finally, I am also going to need from game data import levels. So I have all I need to get started. And now I just want to create a class level. And in here, we are going to need an init method, as always. So when I initiate this class, I want to know what the current level is going to be. And that is information I can use to pick the right information from these levels. So essentially, I'm going to use the current level to choose whichever one of these levels is going to be the one I currently want to open. And then besides that, I need a surface to know what I am going to draw on. So this one is what we always have. And then here, let me add a comment and let's call it level setup. Now the first thing is self.displaySurface is just going to be surface. And then self.currentLevel is just going to be the current level. And now we can use that information to pick the proper level from these levels. And first of all, I want to get my level data in general. And all I need from here is levels and then my current level. So this current level is going to be an integer between 0 and 5, and I can use that with each of these keys. And this would give me the whole level. But I don't really want the entire level. Instead, what I want is the level content. And that is just going to be the level data. And in here, I want the key content. So if I go back to my game data, let's say we picked with current level 0, and in level 0, we have the content key. And in there right now, we have this is level 0. So this would then be the actual content of the level. Now, besides that, I also want to set a self.new max level. And this is going to be the level we will unlock. And this is information we also have, because this is inside of the unlock key. So back in my game data, this is this key in here. And with that, we have all the information we are going to need to set up this level. So now let's call it level display. And in here, we're going to add all the stuff we actually want to display to the player. And first of all, since we want to show some text, we need a font. And for this one, I'm just going to use the default font for Pygame. So pygame.font.font, none, and let's say 30. Actually, 40 is probably better. Then from that font, we have to create a text surface. And this is going to be self.font.render. We want to get the level content, then true for anti-aliasing, and for the color, let's go with white. And then self.text_rectangle is going to be self.text_surface.getRect. And I want to set the center to screen width over 2 and screen height over 2. And that way we will just draw a basic piece of text in the middle of the window. Now, once we have all of that, I can also create a run method for this level. And all I want to do is self.displaySurface.blit and then get the text surface and the text rectangle. So self.textSurface and self.textRectangle. And this would then be a very basic level. So with that, I can go back to my main file. And in here, from level, import level. And then inside of my game class, I can create self.level. And this would be level. And in here, the arguments we are going to need is the current level and the surface. Let me copy them again. And the surface, again, is going to be screen, just like we have seen for the overworld. And for the current level, let's go with 1 for now, so we have the same as in the overworld. And now instead of overworld.run, I want to run my level. And let's try this. And there we go. We can see level 1. And if I change this to, let's say, 3, we get this is still level 1. So there has been a mistake. Oh, and the mistake is just that I said 3 for the overworld, not for the level. So now let's try this again, and there we go. Now we can see level 3. So this level here, in the most basic sense, is going to work. So now we have to figure out how to load each of these levels. And more importantly, we have to connect these two classes. So let me draw this. Let's say the overworld, we're going to keep in yellow for now. So here we have our overworld, and from the overworld, we want to go either to level 0, or we want to go to level 1, or we want to go to, let's say, level 2. So in the overworld, we have to know what level we are on. But then we also have to be able to go back the other way. So if we are in level 0, we also want to go back to the overworld and load level 0 so that our player starts in the right position. But the problem that we have with this setup right now is that both of our classes are inside of the game class right now. So we have to figure out how to connect these two classes with each other. And the key to make this work is to have methods inside of the class. And this is something you hear all the time when you start to learn Python, that anything in Python is an object that you can pass around, including functions and methods. And early on, this really doesn't mean all that much to you when you are a beginner. But in this case, it's actually incredibly useful. And the more you work with different classes and need to connect them, passing around methods is really useful. So let me explain what I am going to do. Essentially, in my game class, I'm going to create another method. And this method is going to create a new instance, let's say in this case of the overworld. And this method we're going to pass into the level, and from the level we are going to call it. And that way we can create a new instance of the overworld class inside of game, but we can call it from the level, and from the level we can also pass arguments into this. And then we are going to do the same thing for the level. So our game class is going to have a level method that we pass into the overworld, and we will also call it from there. And that way we can give this method a couple of arguments from inside of our overworld, but actually call it inside of our game class. And I think it's best to do all of this in code. So let's go through this step by step. So here we are back, and let's say I want to create a new method that creates a level, and let's call it create level. We need self, and for now let's just leave it at that. And in here, just to demonstrate how this is working, I want to print create level. And now this create level I am going to pass into my overworld. So self.create level. And you really have to make sure that there are no brackets after this. So these two brackets should not be there. We are not calling this method, we are just passing it around. And when we run all of this, I want to run my overworld. All right, so now inside of our overworld, I have to pass in another parameter. So let's call this create level. And I guess we can put this next to our setup stuff. So self.createLevel is going to be create level. And now when I get the input in here, I want to check for another elif statement that is going to be keys and then pygame.k space. That was terrible spelling. So we're just pressing the space button. And once we're doing that, I want to call self.createLevel. And now let's actually run all of this. And now I print this and we get create level. So we created the method inside of the game class, but we are calling it from inside of the overworld. And what is even more powerful is that I can give this one a couple of arguments. So let's say I want to know the current level, something that actually will become important in just a second. And I just want to print current level. And now in my overworld, I can pass this argument in there just like I'm doing for any other method or function. So self.currentLevel. And now if I run this and I press space, we get 1. If I move to the other one, we get 0. If I move to the next one, we are going to get 2. So this one is working really well. And now this information we can use to create another instance of the level. So now I want to create my current level. So early on, we just passed in 3 here as a random number. So it doesn't really matter. So this one was fairly random. But now we're going to pick the level we are currently on in the overworld. And as a matter of fact, I don't actually have to create this level in the init method. But I do have to create something else now. Because now when we're creating this level, we can't really see it. So it's kind of pointless. So we have to figure out in our run method to switch between the 2 different states of our game, where we either have the overworld or the level. And I have done this by creating another attribute I called status. And by default, this is going to be overworld. And then in the run method, if self.status is equal to overworld, then I am running my overworld. But if that is not the case, so else, then self.level.run. And then every time I create a level, I am also going to change self.status to, let's put it at level. And now with all of that, let me run the game again. And now on, let's say level 0, let me press space, and there we get level 0. Now, right now, there's no way for us to get back, but the basic mechanic is working. And the key component to make all of this work is to pass this method inside of our overworld. And that way we can move data around very easily. And well, now all we have to do in the level, we have to get some kind of input in here as well. So let me give it another input method. And I guess in here I can just copy a basic few things from my overworld. So that if keys, and let's say in this case, if we are pressing space, we are winning the level. If we're pressing escape, we are failing the level. And enter in Pygame is called pygame.return. And if keys pygame.escape, then we want to do something else. And now in here, we have to figure out another method that brings us back to the overworld. And this, again, has to be done in a very similar way compared to this create level. And I guess this could be a pretty good challenge for you. Try to create another method in the game class to load another instance of the overworld and call this from inside of the level. Now this is going to need a couple of parameters, but I'm sure you can figure it out. Alright, let's do it together now. So I want to create a new method and let's call it create overworld. And self is always a given. But in my case, I went with two parameters. The first one is the current level and then the new max level. And now in here, I want to create self.overworld and give this one a new instance of the overworld class. And in here, we are going to need a couple of arguments now. And let me copy all of the parameters of this class. That should make our life a bit easier. So we need start level, max level, surface, and create level. And let's go from the easiest to, I guess, the hardest. Surface is probably the easiest one. That one is just going to be our screen. And the same for create level. Those are given methods that we don't really want to change. Now, start level is just going to be the current level. So inside of our level, we would just want to go with the actual current level we have in there. And now the last bit we need is the max level. And here we have a minor problem because we are going to override this max level, but we only want to do it if we are winning the level. So if we are failing the level, we don't really want to touch max level. So we have to add an if statement here that if the new max level is greater than self.max level, and only if that is the case, self.max level is going to be the new max level. So only if we are unlocking a new level, we are going to change this number. If not, we are not going to touch it. And well, then the max level can just be self.max level. So it's either going to be a new max level or the same we had before. And now with this, we have the entire method. And now whenever we create a new level, so in here, we want to pass this method also in there. So create overworld, and I realized I made a spelling error. That's better. And really what I want you guys to think about here, when we call this method, we are passing in information from two different sources. First of all, from this create level, we are going to get the current level we are on in the overworld. And this we are then also going to use as the first argument. However, then the second argument, create overworld, is going to come from the actual game class. And this way, this method here is combining lots of different sources of information, which is incredibly powerful, especially if you have a larger project. Because this way you can pass around information basically however you want. And well, the last thing we have to do, back in our level class, we have to give this another parameter. So create overworld, and let's put this at the end of level setup. So self dot, I think my A key isn't really working. So create overworld is going to be create overworld. And now in this statement here, so I guess this one would be once we are winning, we want to call self.createOverworld. And now we have to pass in a couple of arguments. And those are going to be the current level and the new max level. And well, the self current level we already have. It's just this one here. So I can just copy it and pass it in here. And the new max level we also have. It's just this one. So those 2 bits of information we already have. They're very easy to get. And now for the escape part, let me copy all of this. Self.current level is not going to change. However, self.newMax level, we can just set to 0. Because we are not going to update any new level if we are failing the level. And since 0 is always going to be smaller than the smallest number we can set here, we are really not going to get across this if statement. And now the last thing we have to do is in the run method actually call self.input. And now let's try this. So let's start with level 0, and we are getting an error that module Pygame has no attribute escape. That should be in level. There we go, Pygame, and it should be k_escape. And now let's try this. And now I can press space, we get to a level, and now I press enter or space, nothing is happening. And the reason for that is that I forgot to set the status. So let me copy it from the level, and now self.status should be overworld. And now let's try this again. And now I can get to level 1. If I press enter, we don't see any change, but we get back to the overworld. And the reason we didn't see any change is because we were on level 1 and we unlocked level 2, which was already unlocked. But if I go to this one, we get level 2, and if I now press enter, we have unlocked the next level. And if I get to this one, and now I press escape, we did not unlock any new level. But if you pay close attention, and I press space, and I enter this level, my player icon is still in the correct position where we left earlier. So all of this is working really well, and I can unlock more and more levels, and if I reach the last level, I don't unlock anything more. So with that, we have our basic setup for a very, very simple overworld style. Now, obviously, this really isn't particularly complex, but this you can expand significantly. As a matter of fact, that is going to be the next part. And again, if you haven't watched the earlier tutorials, you are going to be very much lost. So let's talk about how to integrate this overworld into the rest of the game we have already made. And let me open this as folders. Here you can see the different folders. On the left side, we have the stuff we created just now, and on the right side, we have the previous stuff. And most of these are very similar. So in the code we made earlier, we already have a game data, a level, a main, and a setting. So the only thing we have to copy over is the overworld. So I'm just going to copy it in there, and that's all we need in terms of files. But obviously we have to make quite a few changes. The most important change we have to make is in game data. So let me open that one. Here we are on the main file of the stuff we made up to the previous video. And the only change we have for now is that now we also have the overworld file in here, the one we just created. Obviously, we can't use it just yet. And in the last tutorial, this was our level data. So this was how our level would actually look like. And this one I want to extend by a couple of arguments. So for this one, this would look like this. And this is the same position we had in the earlier node. And besides that, I also want to give it the unlock parameter. So just this one. And now we need one additional argument because I want each of the nodes to be animated. So we need some animation sprites. And this is just another item in here that looks like this. So we have node graphics, and there's a folder called graphics/overworld/0. So here we have all of our files, and if I go up a folder, there we have our graphics. And so far we know most of these, but the one new folder now is called overworld. And in there we have the folders 0, 1, 2, 3, 4, and 5, and an image called head. And if you open, let's say, for example, 0, we have different animation frames. And this is what we actually import. And be aware, in the earlier tutorial, this folder did not exist, so you would have to add it. And all right, this would then be one level. Now, if we only had one level, it would look a bit boring. So I made a couple more myself. And this is going to look like this. So, well, quite a lot of different data, but all of this has been made in the tiled editor. And the only thing I changed was the name. So here we have level 1, here we have level 2, and I ran out of motivation after level 2, so level 3 gets the data from level 2. But the node position and the node graphics and the unlock are different. So in the overworld it looks different, but the level itself is always level 2. But, well, you can make a whole lot more levels in this way, and it should be quite easy to make more. And, well, now the final thing that we are going to need is the dictionary with all of the levels. So let me copy this one in there, and there we go. Now, we just have to import these levels and we get access to all of this. Let me actually minimize all of them so they're a bit easier to read. There we go. So this is then all of our data for our game. So with this one, we have fixed our game data. Next one, we have to look at our main file. That's probably the most underworked right now. And here we have to create our game class. So let me open the previous main file. This one looks like this. And in here, I just want to copy the entire game class. And I just want to create this in here. Then I can delete this level here because we don't need it anymore. And instead, I want to create an instance of the game class. And then in our game loop, I want to run this game. So technically, this should already give us the overworld by itself. It does not, because again, I forgot to import the overworld. So let me from overworld import overworld, and let's try this now. And now we can see our overworld. Now if I actually open level, we are going to get an error, but that's kind of expected at this point. But anyway, it is working for now, so good start. So what we have to figure out now is when we create a level, we need these different arguments. So I can close my previous main file, and now I can look at my level. So this one here. And in there, I want to get these 3 arguments. So what we have in here, I can essentially delete. We don't need it anymore. And let me just copy what we have in here. So we want the current level, the screen, and self.createWorld. The self can go. And I guess the best way to approach this is to add another section here, and let's call it the overworld connection. That's probably making the most sense. Now the first argument we want in here is self.createOverworld. And this is just going to be create overworld. Then next up, self.currentLevel is going to be the current level. And this is just going to be the current level we already got here. So this way we already got one parameter out of the way, and with create overworld, we have the other parameter out of the world. And screen is, well, very easy to get, because that we already have. That's just this surface here. So I can just rename this to surface, and we should be good to go. Now, next up, when we created all of the different layers, we always had a file called level data. And this I want to create now. And this also is fairly easy. So I want to have my level data. And this is just going to be the levels that I get from game data. So all of this, and actually we do have to import all of this. So from game data import levels. And in here, I just want to get the key with self.current level. And then the final bit I need is self.new max level. And this is going to be my level data. And in here, the key we are looking for is called unlock. So I guess let me just open the game data and let's look at level 0. So in here, all of these are the layers for our game. And we get all of those with all of this code here. So here you can see all of the keys we are going through. Then the node position we use in the overworld, that still works. Unlock is what we use here for the new max level. And the node graphics we are going to have a look in just a second. Let's actually try to run this. And let's go to level 0. And if I run this, there we go. We have our basic level. And now the problem we have is that there's no way for us to exit this level. So if I hit the end, nothing's really happening. And also if I leave the screen, well, nothing is happening. So that is something we have to work on now. That in the previous example, we could just press enter or escape to leave the level, but we don't have that right now. So let me actually minimize all of the different methods so we can work with this a bit easier. This is actually a really long class by now. All right, there we go. So in here, I want to create a couple more methods. The first one I called check def. Needs self and nothing else. And the collisions with the enemies I am not going to cover for this tutorial. So the only def state we have for now is if the player falls off the platforms and goes below the screen. And this we can measure very easily. All we need is self.player.sprite.rect.top, so the top of our player. And if that is greater than the screen height, we know the player has left the screen. And if that is the case, I want to self.create the overworld. And in here, we are going to need 2 arguments. Let me copy them actually. So we want to create the overworld. And here we have create the current level and a new max level. Now the current level is just going to be self.current level. So what we have in our init method, this one here. And since we have failed the level, there's no new max level. So this can just be 0. And with a def state, we also need check win in case we are winning the level. And in this case, we are just hitting the end of the level and colliding with the head. So the first we need is a sprite collision. So if pygame.sprite.sprite collide, and then here self.player.sprite, and we want to check it against self.goal. And then you can work with the do kill argument. In this case, it really does not matter. I'm going to set it to false, but both options are fine here. And if that is the case, we have won the level. So then I want to call self.create overworld again. And in here, self.current level can remain exactly as it was before. But for the new max level, we want to get self.new max level. And this way, we should be able to return to the overworld. The only thing we have to do now is to actually call these 2 methods. And where am I going to call them? Let's put them right at the bottom here. So we have self.checkDef and self.checkWin. And now in my main file, we get invalid syntax. Let's go back to the level. Let's see what went wrong. This should be if, and this should be indented. That's looking much better. And now let's try this again. I can still see the overworld. If I run this now, we can see the first level. And now if I jump off the cliff, we go back to the overworld. And as a matter of fact, now, if I go back to the final level that is unlocked right now, and I go all the way to the end of the level, let's hope I don't fail in the process. So there, if I touch this now, we have unlocked the next level. So again, this is working really well. So this is also working quite nicely. Cool. So with that working, the last thing we have to do is to make the overworld look much nicer, which actually isn't all that hard. And I guess I can close all of the other files that we don't need anymore. So this way, it's a bit easier to see what we are working on. And let's start working on the overworld and let's see how far we get. Now, the easiest part to work on in here is the player icon, because we only have to make one little change in here. That instead of having a plain surface as an image, we want to import a graphic. And what I want to do is to get pygame.image.load, and the path to the file I want to load is this one. So in the overworld file in graphics, we have the folders for the animations for the nodes, but we also have a file called head. And once we have that, I can run this again, and now we get a very stylish head that works and makes the whole thing look much better. Cool. So now back in the overworld, I can close the icon, and that's all we need for this one. Now, next up, we have to work on the node. And this one is going to need a few more things, because now it has to be animated. And since we're animating, we first need a couple of animation frames. And for that, we have to import a whole folder. So import folder, and this one is going to need a path. We get this one from the support file, this one here, that we made earlier and already used a whole bunch. And then when I create the node, I also want to get the path. And we're going to set this one up in just a second. But besides the frames, I also want a self.frame index. And this by default is just going to be 0. And then for self.image, I want to get my self.frames and then self.frame index. And now next up, for the status, we are not going to fill the surface with a single color anymore. Instead, I'm going to turn this into a proper attribute. And let's call this available, or self.status is going to be locked. So with that, we have the proper init method. Next up, we will need an animate method. And in here, we could use inheritance to make this a bit less on the writing, but well, in my case, I'm going to be a tiny bit lazy here and just copy paste the animate method from the animated tile. And just paste it in here. And once we have that, I can call the update method. And now I can just call self.animate. And before I forget, import folder we don't have yet. So from support import folder. I keep on forgetting to import the proper modules. But all right, now with that, we have our basic node. The next thing we need is to actually set a path to the file. And this is going to happen in the overworld. And let me minimize anything besides setup node, so we can actually read what's going on. In here, we have to add a path. And I think this could be a pretty good exercise. So for both this line here and this line here, we have to get the path from our game data. So try to figure this one out yourself and see how far you get. All right, let's do it together now. And first of all, let me open the game data. This one here. And we are already using all of this. And as a matter of fact, inside of our overworld, we already get node data and node position. So we are already getting this node position here. And well, to get the path, all we need is this node graphics here, which we can access in just the same way. So all I really want is to get my node data, pass it in here, and then get the node graphics, I think I called it. Let's double check. And yeah, node graphics. And this I can just copy and paste into this one as well. And now this should be working. Let's try. And there we go. Now we have our different stages. Obviously right now the path between them looks terrible, and we don't disguise the locked stages yet, but step by step, this is already really good. Also, nothing's animated, but that is actually the easiest part to solve. Because now in the run method, I can also call, let's put it up here, self.nodes.update. And let me add one line between the updating and the drawing. And now if we run this, there we go. Now we get animations. So this is looking quite good. Now I guess next up, we can minimize the setup nodes, and the path looks the weirdest right now. And for this one, we don't really have to change all that much. All I did was change the color from red to this one, which is a dark brownish color. And well, if I run this one now this feels much better. So the change here is fairly minor. So we are almost done. The last thing we have to do is in the node, we actually want to either display an animation if the node is available, or we want to gray it out if it's unavailable. And this is going to happen in the update method in here. And the first one we can work on is if self.status is equal to available. And only if that is the case, we want to animate this particular node. And if we run this, you can see that only the available stages are animated, everything else is static. So this is working. But obviously it still doesn't look very good. So instead, I want to add an else statement. And all I really want to do in here is to turn the entire thing black. And for that, we are going to need something I haven't covered yet. So let me go through it step by step. First of all, I want to create a new variable that I call tint surface, short for tinted surface. And here, we're just going to get self.image and get a copy of that. So literally all we're doing, let me scroll up a bit. We are getting this image and we are making a copy of it. And now this copy, we are going to fill black. And this happens with tint surface.fill. And now we need a color. And we could just go with black here. And then we can self.image.blit and put our tint surface on top of that. And the top left for the position needs to be 0 and 0. And let's just have a look how this is going to look like. So if we run this, we are getting an error because I added a B in there. Now let's try this, and there we go. Now the problem is, when we are drawing the rectangle on top of that, we are just filling the entire square here, which really isn't ideal. So we want to add some code here that we hide all of the invisible sprites. And this we can also do quite easily. So if I go back to the overworld, for this fill method here, we have to add 2 more arguments. So inside of this fill, besides the color, we can also pass a rectangle and a couple of flags that determine how the transparency is going to work. Now for the rectangle, I don't really want to use a rectangle, so I just add none in here. But for the flags, I want to add pygame.blend_RGBA/multiplier. And if I run all of this now, we can see that we are hiding all of the pixels that aren't used by something else. So with this, we have some nicely hidden and locked away levels. And let me try a level and see if I can unlock the next stage. And let me go all the way to the back, and there we go. Now we can see the next stage has been unlocked. So this is still working just fine. So with that, we are very nearly done. The last thing we need right now is that our background is an ugly gray. So in the overworld, I also want to create this sky. And the sky we already kind of have, because in our decorations, we have the sky. Let me minimize everything in here as well. So I just want to create an instance of the sky in the overworld. And well, this we can just do in our sprites. So self.sky is going to be the sky. And for now, sky wants one argument, and that is the horizon. And let me set this one to 8. Now, before I forget, from decoration, import sky, ideally spelled correctly. And now in the drawing part, I want self.sky.draw and self.displaySurface. And now let's try this. And now we can see a background. But now we do have a bit of a problem, because when we have a level, in here we have the clouds, and this looks okay, so we can get away with a pretty simple sky. But if I go back to the overworld, in here this looks far too, well, generic, I guess. So we have to add a couple of things. And in my case, I added some palm trees and some clouds, and they were all in the same color as the background bottom part. So this darkish brown, reddish color, whatever this is. So this we have to add. And it would be a shame here to create a whole new sky class. So instead what I did, I updated all of this and made it a bit more complex. So let's go through it. First of all, I want to add another parameter that I called style, and by default, this one is going to be level. And now at the bottom of the init method, self.style is going to be style. And now if self.style is equal to, let's say, overworld, then we want to do a couple of things. First of all, I want to import what I called palm surfaces. And for this, we are again going to use the import folder. And the path for that is going to be this. Oh, and this is actually a mistake I made about 10-20 minutes ago, that in our overworld folder, there were a couple of folders missing, specifically palms and cloud. So let me quickly open the folder just to be sure. So this is how the overworld folder should be looking like. We have the folders 0 to 5, and those contain the graphics for the nodes. Then we have clouds, just some basic clouds, and then we have the palms, and just a ton of different palm trees. And then we also have our head. And I guess besides that, the other thing that changed, if I go to the top folder, in levels, there's also 0, 1, and 2. So in our game data, this is all of this data here. And at this stage, our project is getting quite extensive, so it's very, very easy to get lost in the data. I guess if you want to make sure, just download the folders from GitHub. There I have separated this and only changed code. Everything else you probably don't want to touch too much. But alright, so back in the sky. Now I have a couple of palm surfaces. And all I really want to do is I want to pick a couple of random ones and then place them randomly on the screen, and then save the rectangle and the surface in a separate list. And well, let's go through it. So first of all, self.palms is just going to be an empty list for now. And then for surface in palm surfaces would give us all the surfaces inside of this list. But I just want to pick a couple of random ones. So instead, I'm going to change this to a list comprehension. And what I want to do is choice from palm surfaces. So we're picking a random item from this, but we don't just want to pick a single one. instead, this one should be, let's say, for image in path 10. And all that it's really going to do is we are going to pick 10 items from this list here. And now in there, I want to get an X, a Y, then I want to use that to create a rectangle. And then in my self.palms, I want to append this surface and the rectangle. So the surface I have here and the rectangle I made here. Now, for the X, I just want to get a rand in between 0 and the screen width. So this is going to cover our entire window. And then for Y, we have a minor problem, because the horizon is going to be a number between, let's say, 0 and 10, because we used tiles earlier. But for this one, we kind of want a pixel position. So we have to convert this horizon. And this, fortunately, we can do very easily. All we need is self.horizon multiplied by tile size. That we also have available in here. So this is then going to give us the horizon of this window. And towards that, to have a bit of an offset, I want to add a random number between 50 and 100. So I guess just to explain what's happening here, if this is our entire window and our horizon is this line here, imagine it to be straight, our horizon line would just be this number here. And towards that, we're adding a slightly random offset. So we're just moving this line up here by a random amount. And now with that, we can create a rectangle, and all we need is surface.get rect, and then the mid bottom I have set to X and Y. And this way, we should be good to go. So now, when we're drawing all of this, I can add at the end here an if statement that if self.style is equal to overworld. And if that is the case, for palm in self.palms, I want to get my surface, so the surface we get from the argument, and I want to blit palm 0, so this would be the surface, and then palm 1, which would be the rectangle. And now in the level, we don't have to change the sky, because this one by default gets this argument. But now in the overworld, when we are creating the sky in here, we can give this the argument overworld. And let's see if this is working. Let's run this, and it does not, because path is not defined. So let's have a look. So overworld, then sky, and in decorations. Oh, and this should be range, not path. I think my brain is starting to fall apart. Okay, let's try this now. And it still doesn't work, because now this surface and this rect should be in a tuple, because you can only ever add one thing in the append method. Now this one thing could be a tuple. Python doesn't care about that, but it can only be a single thing. There can never be two arguments. Now let's try this, and there we go. Now we have some palm trees. And if we run this again, we get a different kind of palm tree. And there we go. Oh, and there's one mistake I made earlier. I realized that, let me actually open the decoration here. And let's move this to the side. I guess you can see it kind of here. And the mistake I made earlier is that this rand int doesn't create an offset in this direction. Instead, the offset goes in this direction, because a positive number in Pygame means you're going down. A very simple thing to get wrong, still happens to me fairly often. But all right. So now for the last thing, we also want to add the clouds in here. And basically, all we need to do for that is to copy all of this and change palm to cloud. And this could be a good exercise for you guys. So in graphics and overworld, there's also a clouds folder for the background clouds, and try to add those in the same method that we used for the palms. All right, so what I'm going to do, I'm going to copy all of this and let's place it here. And now let's go through it step by step. First of all, this should be called cloud surfaces. And then the folder is also called clouds. Then the list is not self.palms, but self.clouds. Now for surface in choice, here we want cloud surfaces. For image in range 10, that's still fine. Then X still works in exactly the same way. This one is fine. Now for Y, we are going to need something else. But the rest actually works just fine. So the one thing we need is to work with Y. So what do we need here? First of all, as always, we need rand. And the top of our window is going to be 0. So this one is still perfectly valid. Now, next up, I want to get the horizon line again. And this one I already have. I used it when we placed the palm trees. So I can just copy this one. And now, instead of adding a number, I want to subtract some. And in this case, let's just go with -100. So now we're moving 100 pixels up every single time. And well, this should be all we needed. So now at the bottom of this, I can add another for loop. So for cloud in self.clouds. And in here, we can just copy this one here and change this and this to cloud. And now let's try this. And this is looking significantly better. And now let me close all of this, change the max level to 0. And the overworld when we start also to 0. And now let's run all of this, and we are getting an error that happens in the overworld in here. Right, and the problem is for draw lines, we need at least 2 points. But if only the first level is unlocked, we don't get that. But all we need to fix this if self.maxLevel is greater than 0, and then we put all of this in there. And now let's run this again. We are getting another error, that we have a syntax error because I forgot the double colon. Now let's try this. And there we go. Now, if I run this game, we get to the level and I can just jump through all of this. Let's hope I don't fail. Okay, that doesn't count. And now we are unlocking the next level and we can continue the process. And if we fail, we don't unlock the next level. So with this, we are having a proper overworld setup. So I hope that... Hello everybody. While I was editing this video, I realized I made a couple of mistakes towards the end. I think the video got a bit long and I got a bit tired. So there are 2 mistakes in particular I really want to address. So let me go through them really fast. They're both quite minor. The first one in the overworld for the icon, the graphic head we imported needs to be convert alpha so that our game is going to run a tiny bit faster. Now, you didn't necessarily need this line, but it does make our game faster. So that was the first mistake I made. Now, the second mistake I made was in the decorations in sky. And in here, the mistake I made was that for our clouds, I forgot in the for loop to change self.palms to self.clouds. So this palms here should have been clouds. And you don't really see this mistake because further down in the draw method, in here we are drawing all the stuff anyway. So you couldn't really see it in the game, but in the code I felt it was kind of annoying. So, well, this was the other issue. Fairly minor, but well, it did annoy me. But now with all of that, the code should be working. Well, it should be working the same, but I think it's a bit easier to read and slightly more performant. So with that, I hope all of that was helpful and sorry for the mistakes. I will take more breaks in the future.